Hello everyone. So today we shall be going through integration by parts. Now the very elegant equation on the board is actually the integration by parts formula. However, actually how we got this is still a dilemma, and therefore deriving this is quite important. We all know the product rule. The product rule, it basically states the following. E by dx of a function uv is equal to u dash v plus u v dash, where u and v are functions and uv is a product of these two functions. Now, getting this formula for integration by parts is nothing new. It's simply getting the integral of this product rule. So if we integrate both sides, what we get is, of course, if you integrate this particular term with respect to x, you're going to get uv, and that is going to be equal to the integration of u dash v dx plus integration u v dash dx. Now it's just a matter of simplifying this and rearranging it. So when you do that, you're going to get, let's just rewrite it as uv equals integration of du by dx v dx plus integration of u dv by dx dx. So this can then be written as integration u dv by dx dx equals, so this comes over here, and therefore uv minus integration of v du by dx. So as you can see, this formula is exactly what we have over here. Now some tutors or lecturers would cancel out this term to give a much more elegant expression of integration of u dv equals uv minus integration of v du. However, for simplicity, I'm just going to keep it at this. So the next question would be, why would we really want to use integration by parts? So what integration by parts allows us to do is to break down a complex integrand into two separate functions. One being basically u, and the other being dv by dx. So we break it down into these two functions, and that allows us to simply integrate this by basically integrating this function dv by dx and differentiating this function u. So let us get into an example to understand how exactly this is done. Consider the integrand x ex dx. So here we must consider x as u, the function u, and e to the power x as the function dv by dx. So with that, we get u is equal to x. So du by dx, which we will be needing later on, is equal to 1. And similarly, dv by dx is equal to e to the power x, and therefore v, which you can compute by integrating both sides, that is equal to the same function e to the power x. Now it's simply a matter of plugging in to this particular formula. So what we get then is, we rewrite the integral e to the power x dx is equal to uv, so that is x e to the power x minus the integration of v, that is e to the power x, into du by dx, which is equal to 1 dx. So when you compute this integral, we know it's equal to e to the power x. And we must always remember to include the constant, which I shall denote as c. So rewriting the entire computed integral, we get x e to the power x minus e to the power x plus c. And let's simplify that, and we get e to the power x minus 1 plus c. So I hope you understood integration by parts through this example and the derivation we did previously. So just as a homework question, let us answer this. Find integration of x square e to the power x dx. And just a hint, you will have to do integration by parts twice here to get the answer. Feel free to post the answer in the comment section. Thank you.